Okay, we're going to be looking at compound interest. Compound interest is something that's really important and is a real life application for percentages. So let's consider this problem. £12,000 is invested at 4.5% interest per year. Calculate the interest earned after 1 year. So let us. So we think, we've got, so basically what we need to do here is find what 4.5% of 1,200 is. And that will give us the amount of interest. So it's 0.045 times 1,200, which gives us an interest after 1 year of £45. Now this kind of question is very simple and doesn't really tell us that much. Compound interest is when each year the amount in your account is going to go up. So this is the kind of question you'd be more likely to be asked. £12,000 is invested at a rate of 4.5% per annum. That's what we had previously. Calculate the compound interest earned after 5 years, over 5 years. So let's have a look at this one. So again, so we've got our 4.5% and we want to find out what the multiplying factor would be. So the multiplying factor is going to be 1.045. So at the end of 5 years. So previously we found that after the end of 1 year the amount goes up by £54. So that £54 would be added to our original amount. So instead of having £1,200 in the bank, we'd have, after 1 year, we'd have 1,254. And then this sum would then be multiplied by our multiplying factor to give us what would be the end of 2 years. So what we need to do is take our original sum of 1,200 and we multiply it by our multiplying factor 5 times. So 1, 2, 3, 4, 5. Now this here, whoops, we're not scoring it out, is the same as saying 1.045 raised to the power of 5. Now we're going to be looking more at indices in the next chapter, so that now becomes 1,200 times 1.045 to the power of 5. Slotting that into our calculator, we get £1,495.42. So the compound interest, so the interest earned is going to be the sum after 5 years minus the original amount, which gives us, after 5 years, £295.42. Now, we'll have a look at a third question. So imagine now we've got £800 and we have invested this at a rate of R% per annum. After 6 years it has grown to £955.24. So we're going to be using a method called the trial and improvement method, which is kind of like an educated guess. So after 6 years of investment, the sum is going to be equal to the original 800 multiplied by 1 plus R over 100. Oh. Not sure. Let's get that. There we go. 1 plus R over 100 raised to the power 6. So we're going to try different values for R. So let's try. Now remember, R is the percentage that we're raising it by. Let's try R to be 10%. So that'd be 10. So that'd be saying that our interest is 10%, which is pretty generous. So if we slot all the figures into the 800 times 1.10 to the power 10 to 6, we get 1417.25. Too big. And it's quite a bit too big. If we think the original, so after 6 years, this has to be equal to 955.24. So, well too big. So let's try reducing it by half. So let's try R equals 5. We've seen our 10's far too big. So again, 800 times 1.05 to the power 6, that's going to give us £1,072.08. Still too big. So we're going to try R2. So when we slot all the numbers in, we get 923 pound. Too small. So we think we've tried 2, we've tried 5, we need to go in between. So let's try R equal to 3. So we slot all our numbers in and we come up with 955.24. Correct. So we now know R is 3%. Now if you were to do an exam like a question like this in an exam, you have to show all the different workings. Put the full details in. If we look back at the original question, use trial and improvement method to find the value. They want to know that you understand what that method is, and this is what that method is. You need to show the working in this. So that is the compound interest, and that finishes off the percentages chapter in the Edexcel textbook. The next chapter will be powers and roots.